Hey, how are you? Welcome to my channel. Today I'm going to discuss this problem which came in CSIR Net 2015 December. Okay, so this question is taken from set C, question number 112. Okay, and you have given this compound which is converting to this compound on application of heat. The temperature was given around 220 degrees centigrade. Okay, so basically it is heating. So you have given four options, and in these options the reactions like Claisen, Cope and in, these three options are given repeatedly. Like they said, either it may be Claisen followed by Cope followed by in, or maybe Cope followed by in followed by Claisen, or maybe in followed by Claisen followed by Cope. That is, they gave all four combinations. So you have to identify which type of reaction combinations is followed to convert this compound to this. Now, before solving this problem, you have to be familiar with these three reactions, that is Claisen, Cope and in. What are these reactions? So let's start with Claisen rearrangement. So what is Claisen rearrangement? It is basically a rearrangement of vinyl allyl ether. So this is your vinyl allyl ether. So this part is vinyl and this part is allyl. Okay, so one bond, one if a sp3 carbon is in between the oxygen and the alkene, then it is called allyl segment, and it is directly, when it is directly linked to the double bond, it is called vinyl. So this, when you apply heat, this is converted into okay, sorry, I should erase this, otherwise it will be confusing. Okay, so this is rearranging like this. Okay, so you are getting this one. So this is your, so this is gamma delta. So from starting from allyl vinyl ether to a gamma delta unsaturated carbonyl compound, this is called Claisen rearrangement. Okay, and in this case, to identify which type of substrate give Claisen rearrangement, you have to number this carbon. So from where the new bond is forming, so between these two bonds new bond is forming, so you have to number like 1 2 3, and from this side also 1 2 3. So this is a 3 3 sigma tropic rear. This is a class of 3 3, this for belongs to the class of 3 3 sigma tropic rearrangement, but the name after it's discovered is called Claisen rearrangement. So the criteria is you have to be with a allyl phenyl ether. Now let us talk about Cope reaction. So it is basically a reaction of this substrate. So this 1 2 3 4 5 6. So 1 5 1 5 die, not conjugated, but 1 5 diene when it is heated. So it will rearrange like this, and same 1 5. So 1 5 diene is again produced, but the substituent pattern alters. So this is also a sigma tropic rearrangement, and it is called Cope rearrangement. Okay, so Cope rearrangement, both case. So you have the criteria is 1 2 3 and 1 2 3. So this 3 3 relationship, this 1 2 3 and 1 2 3, or you can say 1 dash 2 dash 3 dash. So this 3 3 relationship is needed for this Cope Cope rearrangement, also Claisen rearrangement. Now let us talk about the third class of reaction which we have to know for solving this problem, and this is called in reaction, or sometimes called Alder-ene reaction, ALDR. So this is the same order for the Diels order the other scientists. So Alder-ene reaction. So what is this reaction? It is basically a substrate like this which has a hydrogen here and a double bond here. So you can say a beta hydrogen. Okay, so this is alpha, this beta hydrogen is there, and you have you may have an alkene, or you may have a carbonyl group, or you may have other compounds. So a double bond, basically a double bond is needed. So this is like this type of reaction occurs. It is also a pericyclic reaction. Heat is needed, and you will get this alcohol. Okay, so this uh, alpha, beta, gamma. So gamma, mm, so this this is alpha, beta, gamma. So beta, gamma unsaturated alcohol you will get. So these three type of reactions are involved here, and you have to now identify the order of their uh, occurrence. Okay, so if you look at the substrate, you first have to identify if there is any segment which can give the Alder-ene reaction, or which can give the 3,3 sigmatropic shift. So let us number. So you can number like 1 2 3. Okay, and then you can number from 1 2 3. See, there is no direct relation between these 3 3 numbering. Okay, there is a oxygen atom here, so these two segments are not related by 3 3 relationship. Now let us number this one also. This one is 1 2 3. So you can see that this 1 2 3 and this 1 2 3 are related as 3 3 relationship, and we just told that if a compound like this is which has 1 2 3 and 1 2 3 relationship, they can rearrange like this. Okay, and this is called the uh, Cope rearrangement. Okay, if oxygen atom is not there, then it is Cope. Both Cope and Claisen are sigmatropic shift and moral and same reaction, but only difference is that for Claisen you should have a oxygen. So in this case it is there is no oxygen, so it is basically a Cope reaction. So only from this substrate, if you apply heat, only there is a possibility of Cope rearrangement, and so we can write this in proper orientation. So this will be our proper orientation, and now this can rearrange like this. So you will get from this you will get uh, so basically this bond is not there because this bond is breaking, and you have this. So oxygen CO. So this here double bond is forming, and here you have a methyl substituent, and here you have a OET group. Now in this substrate you have to again number to identify what type of reaction can happen. So now if we so you may it is clear that this double bond is totally isolated from this system, so no relationship can exist between this double bond and these two. So there must be a relationship between this double bond and this. Let us number. So this is 1 2 3, and this is 1 2 3, and you see this segment, this particular segment, which I can mark with some color. So this particular segment, this one. Okay, so this is actually vinyl part, and this is your allyl part. So you have allyl vinyl segment, and I have just told you that allyl vinyl segment will undergo, under heating condition, it will undergo uh, Claisen rearrangement. So Claisen rearrangement is basically this will attack here. No, not attack like I cannot say attack. This is a pericyclic reaction, but we represent it like this. So it will go here. Okay, so it is maybe clearer if I erase this one. So what is happening actually is, so this is a this arrow I am pushing here, this will go here. So this is basically, you can write it in more proper way like this. If you have to write it in more clear way, you can write it like this. So this is your vinyl part, and now this is your allyl part. So this will push here, now this will go here, and this bond will break here. So what you will get is, you will get something like this. Sorry for the cyclohexane. You will get something like so here you are forming a keto. So this, after breaking of this bond, a keto group will be formed here, and you have your methyl group here. Okay, now this is same, and you just, this ethyl OET group will go down and a new group is adding here. So you are adding a group like this. Okay, so this 1 2 3 3 carbon, 1 2 3 3 carbon. So your this part is complete. You can see your this part is complete. Now a bond is forming over there. So you finished the three, you finished the three parts, that is two parts, that is Claisen rearrangement and the Cope, first Cope rearrangement and then the Claisen rearrangement. And now you are left with only one option, that is in rearrangement, but you have to find the right combination. Now if you open this hydrogen like this, you can see that this part is perfect for in reaction. So this is your carbonyl, and here you have a double bond and you have a hydrogen. So this part, this carbonyl, a double bond, and after that a hydrogen, alpha hydrogen. So it will do in reaction like this. So I can push the arrow with different color. So this is the arrow pushing mechanism of in reaction. So this is your H in reactions, and after that reaction you will ultimately get this oxygen here. Okay, so this is your OET group, and now your double bond is forming here. So this is your product matching with this same product. So if we find out that the reaction order would be, first it is Claisen, sorry, first it is Cope, first it was Cope, then Claisen, and then in. And I don't remember which option was there, but this would be the uh, correct order of the reaction. So Cope followed by Claisen followed by in reaction. Okay, and I hope you understand the video and I am able to explain the whole problem. So if this video is helpful to you, then give a thumbs up and share this video with your friends, and don't forget to subscribe my channel.